Hello everyone, today we're going to continue 20.1, day 2, and we will be finishing the lesson today. We will continue to find the circumference and area of circles, more on finding area though. So let's take a look at the very first example, applying the area formula. Problem A. A rectangular piece of cloth is 3 by 6 feet. What is the area of the largest circle that can be cut from the cloth? Round to the nearest square inch. So since we know that this piece of cloth has a dimension of 3 feet by 6 feet, if we're trying to cut a piece of the cloth, the biggest circle that we can make is probably as wide as it is. In other words, the diameter will be 3 feet, which means the radius is going to be 1.5 feet, and since 1 foot is equal to 12 inches, if you multiply 1.5 times 12, we will have 18 inches. So, or you can think of it as, since the diameter is 3 feet, that will be 36 inches, and then the radius will be half of that, which is 18 inches. So either way, we will have the radius to be 18 inches. So now proceeding to find the area of this circle, that will be area equals pi r squared. So we're going to substitute the 18 inches that we found inside, and we will have 324 pi square inches. But if we were to let pi equal to 3.14, we multiply that by 324, we will have the area of the circle, which will be about 1.1017.9, or about 1018 square inches, and that will be the area of the biggest circle that you can cut out of this piece of paper. And that's the end of the problem. Next problem. A slice of circular pizza measures 9 inches in length. What is the area of the entire pizza? Use 3.14 for pi. So we are given the pizza slice measures 9 inches, which means the radius of the pizza is 9 inches. So to find the area of the entire pizza, we're just going to use the same formula, area equals pi r squared, which means it's pi times radius, which is 9 inches squared, and that'll give us 81 pi inches. Again, if we substitute 3.14 inside for pi, we will have approximately 254 square inches for the whole entire pizza. And so that will be the answer for this problem. Number 8, continuing from the same pizza question from above. Suppose a slice of pizza represents 1/6 of the whole pizza. Does this affect your answer to 3b? What additional information can you determine from this fact? So it should not affect the answer for the previous problem, because the entire pizza is still going to have the same area. So what you can determine is from here that the area of one slice of pizza, so let me draw one slice of pizza, is equal to 1/6 of the area of the circle, the entire pizza, which is 254. So if you take 254 divided by 6, you will have approximately 42 inches squared for one slice of pizza. Okay, and that's the end of the problem. Number 9, a circular swimming pool has a diameter of 18 feet. So I'm drawing the diameter for the pool, which is 18 feet. To the nearest square foot, what is the smallest amount of material needed to cover the surface of the pool? So of course we want to use the least material. That means we are going to cover the entire area of the pool. We're going to start with the area is, the diameter is 18, so therefore that makes the radius 9 feet. And so using the area formula, again, it's going to be pi times 9 squared, which will give us 81 pi, and that will be square feet. And again, substituting 3.14 for pi, you will have approximately 254 square feet for the area of the pool. And that is the end of the problem. Number 7. Stella measures the diameters of a nickel, a dime, and a quarter. There are 21.2 millimeters, 17.8, and 24.5 millimeters respectively. Find the areas of each coin. Round to the nearest 10. So for this problem, we need to find the area of each coin. So the diameters are given. So we need to actually start with the radius of each coin. So for the nickel, the radius is going to equal to 10.6 because it's half of that millimeter. And then for the dime, the radius is going to be 8.9 millimeters. And then for the quarter, the radius is going to be 12.25 millimeters. So now we are ready to find the area of each one. So for the first one, it's going to be pi times 10.6 squared, and if you do the math, multiply it together, you should have about 303 millimeters squared. For the second one, it's going to be pi times 8.9 squared. Multiplying it all together, you will have approximately 247.8 millimeters squared. And then the last one will be area is pi times 12.25 squared, which is approximately 471.4 millimeters squared. And that's the end of that problem. Number 9, divide each coin's value in cents by the coin's area round to the nearest hundredths. So we will take, for the first one, the nickel, we're going to take the area, 353, divided by, actually the other way around. The nickel's cost value is 5 cents, so we're going to take 5 divided by 353, which is approximately 0.0. Let me do the math. Hello. 5 divided by 353, 0.014 per millimeter squared. For the dime, it's going to be 10 divided by the area, which is 240. I think it was 248.8, and you will have approximately 0.04 per millimeter squared. And then for the quarter, it's going to be 25 divided by 471.4, which is approximately 0.05 per millimeter squared. So those are the values for each one of the coins. Number 9, which coin has the least value, and that will be based on the numbers, the nickel. And that's the end of the lesson for today. So go ahead and get started with your assignment from Google Classroom.